Hey, what's up, guys? So this is going to be part 2 for the radar gun project that you might remember from a while back when I took an off-the-shelf Bushnell radar gun and wired up an Arduino Leonardo into it to basically sniff the LCD segments from the screen, and then from that I was able to get the speed readout into my Arduino project, and then from there you could do whatever you want with it. In this video, I took things a step further and basically took that Arduino Leonardo and miniaturized it down to a tiny little board that solders directly down to the Bushnell radar gun control board. So here it is, and I'm able to power it directly from a 3.3 volt supply, and I even have a micro USB connector on there. So let me just give you a quick demo of what this does. So I'm going to adjust the camera here and you'll see what's going on. Okay, so I'm just going to apply power now to the board. And as soon as I apply power, you don't see anything happen here on the screen. And that's because the microcontroller board can actually control the radar gun via the push button signal. So usually there's a button right here that you have to press to turn the gun on. And you can see that the microcontroller board not only turns the radar gun on, but it's also able to pull the trigger to start it to actually scan for a speed. And now, since I've got the USB cable hooked up, I can go over here, make sure that I've selected that as the port, and then start the serial monitor at 9600. And all this code does is just stream out the speed. So I'm just going to wave something in front of it. You see we had 25, and it's only displaying changes in speed. So right now it's sitting at 0 speed. But if I wave something, there you see 27, and then it goes back to 0. So pretty cool stuff, and that's all this code does, and the code's pretty much the same as before, and we can review that slightly because a few things had to change with this microcontroller board, but nothing major. So in this video, I'm going to go over everything you need to actually get one of these boards installed into this radar gun. So let's go ahead and get started. All right, now the fun starts. So we need to talk about everything you need to get one of these boards made and soldered into one of these Bushnell radar control boards. So this is what it looks like soldered in there. And you can kind of see that I actually designed the board to mate up right in there. So let's see if I can get that to focus. So the LCD screen on here has these through-hole pins, and I have those pins so that they actually line up with the pads right here on the radar board. And there it is right there. And I have another one of these radar control boards that we're going to actually go through and solder this one into it live. So, so to get this board made, head over to the wiki I've got for this, and you can see I've got all of the legacy tutorial stuff in here, all of the pinouts, that video, that original code, and then now you get down to the radar board. So this is where we're working at, and I've got the schematic here and the manufacturing files. So here's the parts list. That's the BOM that you can just go and upload right into DigiKey and get all the parts. And then here's the Gerber zip. So that's a zip file with all of the Gerber files that you can go and upload to OSH Park, PCBWay, wherever you want, Gold Phoenix. But what I did to get this board made is I actually used Electro Dragon. So if you shoot over to Electro Dragon, you can go to PCB Service 2-layer, and they're not sponsoring me or anything like that. I just use these guys. So this is pretty straightforward. You know, I'll just kind of whip through this real quick. The smallest option. I don't care about color. Actually, I just did a batch of these and tested out yellow. Kind of look cool. But anyway, let's see. Green, the standard thickness. These are new options, actually. No express, no panelization, and no extra requests. And I usually always do lead-free, too. Then you can just upload that zip right here, add that to your cart, and then if you're going to do this the right way, in my opinion, you want to also pick up a stainless steel stencil, okay? And this is pretty cheap. smallest option, topside only. Choose that same zip package here, and then always put in here top. Oh wait, let's put use top. Oh, you can see that I type that in a lot. Use top paste file, and they'll know when they open up that Gerber zip package to look for the top paste file. And I never confirm, and then just add that to your cart. And that's only 15 bucks, and that'll save you a lot of grief. So once you get all the parts in, you get the bare boards in, then you can actually go through and apply the solder paste to the board with a squeegee and all of that. Tweezer on the components, and then with a hot air rework station, you can reflow the board. There's several different ways you can do that, of course. But I actually made I'm looking for it right here. I made a video here that you can watch, and this is exactly the way I do it. So if you check that video out and go to the description, you'll see all of the stuff that I use. So I'm looking for the tools. I've got the tools, I've got the solder paste, everything. So check that out. So now you've got the board made, then you need to load it with the Arduino bootloader, which I also made a video on how I do that. So this is using the famous Nick Gammon sketch with another Arduino. We're going to go through that because this board is actually, it's never been tested. I actually don't have any code in it or anything, so we're going to do that live. But just so you know, heads up, I've got a video here on how to burn the bootloaders. And so check that out, and we're just going to go ahead and do this live. So let me go ahead and get set up here. Okay, so I've got my Arduino. This is an old Arduino, Duemi Lenovo. This is the one I use to program all of my bootloaders. So I just let it sit there on the shelf with this ribbon cable hanging off of it. And let's see, we're going to go ahead and plug this in, make sure that we've got pin 1 lined up with pin 1 down on the radar board. And I did put, I'm just checking there. Yeah, I did put a little 1 there on the board. Okay, so that's plugged in. I'll zoom in on that a little bit. And just a quick warning, the programmer Arduino, this guy here, is running at 5 volts. And it's actually going to power the target board through the AVR programming header here. So keep that in mind, because if you forget to burn the bootloader before you attach it to the radar control board, this is going to be running at 3.3 volts. And you don't want to program this once you already have it installed. So keep that in mind. Now there's ways to get around that. You just need to find another Arduino that's running at 3.3 volts and then disconnect the power pin and you'll be fine. So I actually have another little cheater board here. Let me rip all these wires off. I occasionally use this guy to burn bootloaders because I'll just power this from the same voltage that the target's running at. All right. So just a quick note there on that. All right, so I've got that set up. Now I'm going to go over and go to Tools and select that as my port. And let's go ahead and start up the serial monitor. Let's make sure we're at 115/200, which we are. And you can see that it already found the ATmega 32U4, which is a good sign. We know it's hooked up right. And then we'll hit G to program it. And there it goes. And we're good. So that's it. So the bootloader's in. Now let's actually test the board out and make sure that it actually can take a program. So since I already have it hooked up to the programmer Arduino, which is giving it power, I'm just going to hook up the micro USB here. There. All right, well, that was kind of interesting. You know, I thought that powering it from the programmer Arduino that I've got over there would be a good idea, but actually that Nick Gammon sketch is always, you know, resetting the target processor and kind of messing with it. So that was actually affecting me being able to program it. You could still power it from the programmer Arduino, just hold the reset button down. So over here I actually have a test sketch, and you can see here it's nothing more than starting up the serial port and then printing hello world to the monitor once a second. So I'm going to go ahead and click Arduino Leonardo, and then now you should see the new serial port here. And I'm going to go ahead and click upload on this. Okay, and then you'll see a compile, and then it's searching for an available USB port. I've got all of these Bluetooth devices screwing things up, but then you'll see there that it eventually found the port and you were able to write and read, and so everything's verified and good to go. So I'm going to launch the serial monitor, and there it is, hello world, continuously. So we're all good. This thing can take a program. So now I'm going to actually put the real code in, and I'd rather put this in now rather than later after I've got everything hooked up. So let's go ahead and upload this now. Okay, we're all set. Just was checking 100% write and read. Okay, we're good. So now that we have the board all set up, I'm going to disconnect that. We can go and take this board now and install it into the radar gun. So let's go ahead and do that. Alright, so now we can get started with the assembly of the board into the control board. So I've got one here pulled right out of a radar gun, and we're going to work through this step by step. So the first thing we need to do is get rid of this ground wire. You can keep it on, but I'm going to remove it because we don't really need it. We'll add our own wires later on. So they gobbed on a bunch of solder right there, and I'll just be able to heat that up and pull it right out. There we go. Nice. Okay, we also don't need this connector anymore. In fact, it's going to get in the way, so let's go ahead and remove that. It's got solder pads on both sides of it, and we have obviously the pads here. Now we've got to be very careful removing this because too much heat will rip up those pads, and that'll be a bad thing. So you can kind of see how I'm going to do this. Let me get my solder out here, and I'm just going to kind of flood the solder all over the place and then just kind of push it out of the way. I don't care if I damage the connector because we don't need it anymore. Alright, so just going to flood it all right there. That's good for now. And then I'm going to put some solder on both sides here. Now these pads, if they rip up, I don't care because we're not using them. In fact, I think they're kind of floating. So now here's the trick. We have to sort of get all of this solder melted at the same time and then pull the connector right off. So I'm just going to kind of do that and then kind of play a little dance here with it. There's other ways you can do this too, but there we go. And it's going to kind of smell like plastic in here. Let's get a little bit more solder over here and here. It's really stuck on there, making a big old mess. There we go. Come on. Oh, it's almost there. There we go. Okay. All right. There we go. Yeah, it's good. Now keep in mind that the first three pads here on the connector are all on the same net, and those are all, if I look at the board here, because we're going to actually tie into those are all at 3.3 volts, okay? And that's how we're going to, well, originally we were going to actually power this board from that, but we're not going to, and you'll see why when we get to that step. Okay, that's pretty good. Just want to be really careful we don't heat up those pads any more than we have to. Okay, so now the board is ready, and we can start soldering the control board or the microcontroller board down. And before I go any further, I just want to mention that you're going to need two extra components. You're going to need a Schottky diode, which I'll have a link to in up on the wiki. Actually, this is a 1N5817, but really any Schottky diode is going to work here. And also a giant capacitor. This is a 680 microfarad capacitor, and we're going to explain why that's needed too here when we get to that step. So let's go ahead and get this on there now. I'm going to get this started a little bit by applying some solder to this first pad here and just get a little bit of solder on there because it's going to make getting it started a whole lot easier. So then I'm going to line these up just like that. Hopefully my chair isn't squeaking too much. There we go. All right, and now we're attached to that first pin. And then from here, we can just go straight down the line. So let's see if I can actually kind of line the board up on camera so you can see that. Now these last two pins are going to be kind of tricky to get to because they're behind this electrolytic capacitor here. So I got to be really careful with that. There we go. Okay, that looks pretty good. So that part is done, which is actually the easiest part. Now we are going to work through the topside pads. So on here we have the ground pad, and that's going to connect right to that through hole where that black wire was at. And then we have the 3.3 volts. We're not going to use that pad. Then the trigger signal, which will go down, and this is probably the hardest one because we have to land it right on this pad here where the connector was. So yeah, that's going to be kind of tricky, and we'll cross that bridge when we get there. Then we have the on-off signal, and this is what actually turns the control board on and off. And that will go down, and that one's pretty easy because we've got a little leg here of this transistor that we're going to solder a little wire to. And that's it. So let's go ahead and get started. We'll do that ground pad first. Alright, yeah, the ground pad's pretty easy, so let's just gob a whole bunch of solder in there, make sure that we got a good connection down. That should be pretty good there. Alright, we're going to come back to the 3.3 volts, so let's move on now to the trigger pin. Alright, so you're going to need a very thin piece of wire, and what I'm going to use is just the clipping off of a standard resistor, and this is what's going to attach from the trigger pad to that third, or I shouldn't say third, to the fourth pin over. So it's going to connect just like that, if you can see that on camera. Fingers were kind of in the way. So I'm looking at the board I just did for reference, and you can kind of see there that little piece of wire that goes over. And this is probably the hardest part of the entire build here. So let's first clean up those pads a little bit. We got to be very careful that we don't damage those pads so they lift off the board. So let me get in there. And I'm just going to apply a little solder there to that trigger pad. And then now I'm going to formulate, or not formulate, but we're going to kind of form the little wire that we're going to stick in there. So I'm just going to kind of bend this tip up a little bit, just like that. And then that is what I'm going to use here. And let's see, this is going to be really hard to do. So we're going to stick it in just like that, and then we'll clip it off when we're done. Okay, so this is going to be tough with all the crap I got around here. And I'm going to be soldering left-handed. So let's see how this goes. Oop. I got it kind of tacked in there, and I'm going to come back to it, but let me just straighten it out. Alright, that looks pretty good. I was just kind of running the soldering iron there through, making sure that we didn't have any shorts in between the pads. Now I can go in there and actually snip that off, and then I'm just going to quickly check it. Okay, that looks pretty good. Okay, and my bench timed out. Okay, now for the on-off control pad. And yeah, this is going to connect over from the on pad to this lead right off of the transistor right there. So that's going to be pretty easy. There we go. And then they probably used lead-free solder, so let me just kind of dilute it with some of my leaded solder here so this goes a little bit easier. And then we'll pick up our wire and then hopefully let's get it there first. Yeah, I think that'll work. Cool. So, by the way, I didn't really get into it in this video, but I actually worked out the signals that control the board. So I had the gun all put together, and then with the button, I was pressing on the button, kind of tracing that signal, trying to figure out how it worked. And basically, it's just like an open collector type output. So all we have to do to mimic what the button is doing is just pull it down low, okay? And then when we're done with it, we, instead of driving it back high, we just tri-state the pin or make the pin a digital input. So reconfigure pin mode digital input. So that tri-states the pin. So when we want to activate or turn the radar gun on, we pull that on pin there low and then hold it for a second or whatever, and then let go and reconfigure the pin as a digital input. The same goes for the trigger. So that's the same kind of thing. So we drive it low to activate the trigger and then let go of it by tri-stating it. And I'll review that in the code and show you how that works. But yeah, I already went through and actually figured out which pins and signals did what. So that was all pretty straightforward. Okay, so now what we have to do is add in the new circuitry. So one of the things I found out the hard way is that when you turn, so you give the board 3.3 volts, right? And then as soon as you turn the radar gun on, it has massive inrush current, so much that it actually browns out the 3.3 volt rail to the Arduino Leonardo down here. So, you know, that's not good because then it just resets itself. It'll actually reset itself and then let go of the on button. So then it just kind of gets into this endless reset cycle. And it's kind of hard to troubleshoot actually because it was like turning on and then turning off, turning on, turning off, back and forth. So I don't obviously have enough bulk capacitance over here to ride through that huge massive inrush by the control board. So that's what this big capacitor that's laying around here somewhere is for. But you can see how I added it on here to this one. So that's what the 680 microfarad capacitor does. And the diode is needed to basically only allow that capacitor to source power to the ATmega32U4. So what we're going to do here is on the anode side, we're going to have our input power go right here down straight to the radar board. Okay, so that's why it's there for the positive, for the 3.3 volts, and then ground right there. And then we're going to tack on the diode. The anode will be there and then go up to the 3.3 volt input there on the board, so that now that power, when it comes in, it'll charge that capacitor up, and the capacitor can only discharge itself into the microcontroller board because we don't want the radar control board to take any of that juice away from the microcontroller board. In fact, we don't care if it browns out down there. We just need this guy to keep that on button pressed in the whole time. And same thing when it starts triggering. That's when you have another massive inrush. So you might also have to play around with that value a little bit too. So 680 seemed to work pretty good for me at 3.3 volts. You might need to bump that up to 1,000, but then, you know, the capacitor starts getting huge. And if you're going to repackage this whole thing up back into the original enclosure, you know, you can't have a massive capacitor out there. But of course, you know, you could wire this down and put this anywhere you want. In fact, I should probably put it on the other side like that. That would probably be a good idea because there is a gap right there in the gun. Yeah, maybe I will do that. For now I'll put it on the top side, who cares? Okay, so let's go ahead and get started. So I'm going to start with the diode here. And then what I'm gonna do is actually use this outside pad here almost as like a strain relief. And that was one of the mechanical support pads for the connector. Okay, so I'm thinking something like that is going to work out. So let me go ahead and get some solder on this pad here first. And then I'll bring it over. Now for this, I'm gonna leave the extra lead length out there because that's what I'm gonna grab onto for the main power wires coming in. I'm gonna see if I can, oops, I went a little too far on it. So I didn't solder the cathode side yet because I gotta slip the 680 through. So I'm just gonna kinda do that. Didn't quite leave enough room there for it. Just make sure to watch your polarity, which, yep, I did screw that up. Okay, that looks pretty good. I'm just going to take a quick look at everything, make sure all of the LCD pins are connected. They all look pretty good. And then look at my handiwork here. Straighten that out a little bit if I can. Okay, so now we just need to add some power wires. Well, I only have red wire, so I'm just gonna have to do a good job of labeling. But for the ground connection, we're just going to throw this right on top of this solder glob over here. That's why I was saying if you wanted to, you could keep that black wire on there if you wanted to. You know, and just reuse that as your ground wire. Okay, so that looks pretty good. And then for the power wire, like I said, we're just going to reuse this extended lead off of the diode, and that's where we're gonna attach our power wire to. Alright, so that's pretty much it. I'm just gonna give the ground wire there a black mark so I don't forget. Hopefully that's good enough. And now we can go and hook this back up and test it out. Okay, so I've got the board plugged back into the gun with the 2 ribbon cables. I've got my 3.3 volt supply. And when you do this, when you first test it, make sure that that supply has a current limit on it. And you might want to set that for about 1 amp because this does pull somewhere around 200 milliamps when it's running. And yeah, I've got everything hooked up. The USB cable's plugged in, and I'm going to go ahead and power up. So here we go. Let's see what happens. And nothing yet. And we should see it power the board up. There we go. Okay, we've got power. And then we'll wait for it to trigger. There's the trigger sign. And then now we can actually go over, select the port. Let's make sure it sees it. Yeah, we've got it. And then open up the serial monitor. Make sure it's set to 9600. And then I'm just going to wave something in front of the gun. Yes, there we go. We got speed output. So it does work. Everything here works. We've got the assembly right. We've got it wired into the control board correctly, and we're good to go. So I did say that we were going to quickly talk about the code here, so I'll just show you that. So you can see on boot up, we've got a 5-second delay there, and then I've got, this code is terrible. It's not really commented that greatly, and even from, it's the original code from the first project, so I didn't really go in and modify any of it. I did throw all that stuff into its own tab over here just to make it a little bit easier to navigate through. But here though, on boot up, just getting back to that, you'll see that we've got the 5-second delay, and that's just to let that massive capacitor there charge up, and let things kind of settle out. So then we go and configure pin 3 as an output, which it will actually turn the gun on. And like I said, that pin, when pulled low, will activate the gun. So that's when it turns it on. We drive it to low, wait 1 second, and then here we go. We tri-state that pin and make it a digital input. 4 seconds later, then we're ready to trigger the gun. You know, these delays you could probably fine tune a little bit, but you know, this is just based on my quick testing. So there's another 4 second delay, and then digital pin 2 now, which triggers the gun to start reading the speed. We configure as an output and then drive that low, and we continue to hold that in as if you're just holding the trigger forever. And then from there on out, it's all the same code. We have a 500 millisecond update rate for which we actually go and check the LCD segments. And I did now actually have to go in here because the original code was working on a genuine Arduino Leonardo board, which is a 5-volt system. So the analog reads are different. So in here, I actually had to tweak these. So now a measured high across the analog read, which you're actually kind of looking at, you know, you're looking at the differences. You're looking at the common pins versus the segment pins, and you're looking for some difference there. And that's what this does. And you can go back and watch that video where I actually kind of get into the details of how all of this works. But now a high would be close to 3.3 volts, which is why I register a segment high pin at 1020 or higher. A low is still about the same, but I set this even lower just to kind of help with noise. So less than 2. So those two things were changed, and then everything else was pretty much the same. I got rid of some debug things, just commented those out, but yeah, everything else here is about the same. So I'll make sure that this code is available up on the wiki and everything else I discussed here. So that is everything on the radar board. Now, coming up, we're going to expand on this, and we can do some pretty cool stuff here. So now that we have everything working on this board, keep in mind that I also broke out a UART on that board. So if you look at it, I know this video is going on forever, but if you look at it, there are some pads over here that are TX, RX, and ground, so standard UART. So you could run that to another Arduino or to a Raspberry Pi, or you could use the USB back to a PC, and you could make your own speed trap out of this thing and hook up a webcam. You could do a lot of cool stuff. So we'll be talking about all of that in upcoming videos, but that is everything you need to know on the radar board and getting it installed into the gun. So thanks for watching.